Okay, so hi everyone, my name is Erin and I've been a software developer for a little over 12 years. Um, Now, Dylan records everything, so don't worry about taking photos of the slides or writing anything down, though you're more than welcome to do that if you want to. But just to reassure you more so you can just focus in the moment, I have business cards that have my blog and stuff on them, and I put a bunch of them on the reception desk. So if you want to take one later, I will have the whole transcript and slides from my talk on my blog in the next few days. So feel free to just relax and absorb. Okay, so tonight I want to talk to you about code review. Software development tends to involve a lot of code review, or it should, because there's a lot of code. And more so as people are using AI to generate code. Supposedly there's lots more code being out in the wild now than there was before, and that's increasing rapidly. So there's going to be a lot more reviewing code, less writing code. So I think, and I could be wrong, but this is going to become an even more important skill rather than a less important skill. Of course, I am all for automation. Don't take that the wrong way. As much as we can automate in code review, we should. But we're barely automating the writing of the code yet, so this isn't getting solved anytime soon. Anyway, despite the amount of time that developers spend on code review, whether that's doing it or dodging it, it's my impression that code review isn't talked about very much. If you're a full-time software developer, I'm going to throw a number out there. I have no idea what the real number is or what other people feel or experience, but I'm going to say you're probably reviewing someone else's code every 2 to 3 days. So basically, my point is not that number, but that we're spending a non-trivial amount of time reviewing code, yet most of us were never taught how to do it. I think most of us just figure it out. You see what other developers write on your code, and that kind of is how you figure out what you should be writing on other people's code and what to look for. But generally, there's no training or guidance. And at some point, you have to start to wonder, is this the best we can do? That's the question I started asking myself a few years ago. And tonight, I want to share a practical and repeatable process that you can use to make your own code reviews faster, more effective, and most importantly, less painful. My hope is that with this presentation, you walk away with something useful and maybe even a new perspective on code review. It's up to you to decide if I accomplish that. All right, so I got my first software development job back in 2012. And one day, maybe 2 to 3 months in, my boss said to me, asked me to review some code. Now, for context, I didn't come into that job with a background in computer science, so I was learning on the job. So hence the delay in starting code review. But when he asked, I was just kind of blank stare, how, what, I don't even know what my question is. I just felt really unprepared. And he kind of looked at me and was like, what? It's time for you to start doing review. You can't avoid this forever, which is fair. To say I was completely unprepared wouldn't really be fair. I had received code reviews at that point, but the code I was writing was so basic and amateur that seeing the reviews I got didn't prepare me that much to review other people's code, which was inevitably more advanced than anything I was writing at the time. But I don't think this is an unusual experience. I think most developers are thrown into code review the same way that I was, where it's just someone asks you one day, like, hey, can you review this? Like, that's the introduction. No guidance, no standards, no best practices, no training, no pairing, no shadowing, no one reviewing your reviews. I am curious, like, if you just want to, like, by a show of hands, how many people had a similar introduction to code review as I did? Just being thrown in the deep end. Yeah, okay, so maybe like half the room, maybe 70%, I would say. I'm very curious to talk to the other 30% and find out what your experience was.
I had a university professor who said that you print out all the code and then you sit in a meeting room and you annotate every line with a different colored pen.
Well, that's what you did back then, right? Software inspection?
I'm not that old, but he was.
So back then, the only thing I could, and I feel like some of you are going to hate me right now, the only thing I could think to comment on was naming, like variable names, method names, maybe a bit of formatting, because at this point in my career, I had read the first 3 chapters of clean code. And so that was the extent of my code review arsenal. Like, if Robert C. Martin had switched the chapters around, whatever the first 3 chapters were, that was going to be it. And for years, that was, my code reviews were just about readability. Nothing about, I didn't know about software architecture or design patterns until later on. Error handling, analytics, logging, none of that. And honestly, I thought I was good at code review. And even more honestly, compared to most developers, I was. I was giving some feedback. And readability is important. So anyway, then I got my second job. After like 2 years, I moved to a different place. Nothing really to report here. I just kept doing my little readability reviews. No one complained. No one showed me a better approach either. My third job was like a complete disaster as far as code review. I ended up with a team lead who could not have cared less about code review. He saw it as a nuisance. It was a blocker. It was slowing things down. It wasn't adding any value. And unfortunately for me, it was only me and him on the team. So yeah, there was no avoiding this clash. So for 3 years, he rubber stamped every pull request I sent to him. No feedback whatsoever. And I swear to you, this guy would audibly sigh every time he saw that I had left feedback on his PR. He just wanted a seal of approval. He did not want my commentary. Most of the time, he would write in response to my comments, is this necessary, or does this matter? Yeah, and every time I would try to be like very constructive and kind, I went through this horrible phase where I thought my delivery could actually change his attitude on code review. I do not recommend going down that route. So at one point, like I felt like I was the problem for saying anything at all. That was the dynamic here. At one point, he sent me this really logic-heavy pull request, and I was in my, oh, if I have a good delivery, that will make a difference phase. And I wrote something like, this is a great place for unit tests, exclamation point, and like a smiley face, thinking that that might work. And he replied, if you want unit tests, write them yourself. That's what I was working with. Just to give you an idea of the level of pushback that I was receiving on a daily basis. But and I'm not giving this man credit for anything here. Like, he was not handling it well, but I will say that it did force me to really double check, like, is my feedback justifiable? Is what I'm saying personal preference, or is it objectively making the code better in some way, whether that's readability, scalability, security, maintainability, consistency? And I started to think, like, I really have to be able to justify my feedback. And even, like, don't even wait for the person to ask. Just say, like, you know, I think we should change this variable name because it will make the code more readable. Or I think we should like change this method because we can make it, you know, less complex. Just go ahead and justify right away. That was kind of my takeaway. I got really careful about removing any sort of personal preference from code review, and kind of, you know, my school of thought now is like, you can't be arbitrary. Personal preference has to stay out of it. Don't even mention it. It's not the place to be like, oh, do you know there's this other way you can do this? No, that can go in a conversation on Slack or something, but not in the official code review. And this started me thinking that as an industry, we really need proof that code review is valuable, that the time you are spending on it is giving you a return on investment. And if I had had that sort of research to back me up back then, I could have just pointed to it. And instead of us having this kind of battle of wills and whose subjective opinion can be voiced in a stronger way, or who's gonna like get exhausted first of arguing, it would just be factual, it wouldn't be personal, and it would have removed a lot of the friction, I think. But I didn't have that. And at the time, it didn't really occur to me to go digging for it. I kind of figured if I haven't heard of this research by now, it probably doesn't exist. I have started looking, but that's like a whole other rabbit hole and different talk. But my main conclusion is there's not much out there, and what there is pretty old and probably doesn't apply anymore. But anyway, that was my third job, catastrophe. At my fourth job, I'll keep this quick because I want to get to the main thing. I worked on a much larger team, and there were still plenty of people who felt my review style just slowed everything down, but there were also people who were open to what I was doing and to the idea that review matters and can improve quality and have impact. A lot of people felt that my pull request descriptions were really helpful. I got in this habit of adding descriptions at a previous job where this guy would always ask me how to test my code. And naturally, I'm an introvert and try to avoid as much human interaction as possible. So I discovered if I just write this stuff down, I don't have to talk to him. That's not the reason we write things down, but if that motivates you, I think that's fine. Anyway, at this job, because people were showing interest, I started writing like internal blog posts, just short things about like common mistakes, things to look for in code review, ways to make your pull requests easier to review. And people read them. Some people even wrote comments. I ended up giving a talk at the company's internal tech summit called Code Review, a skill worth investing in. And one of our directors saw the talk and really liked it. And when he moved to a different company, he invited me to give the talk there. And it got like a lot of conversation going. And it just seemed like people have questions, a lot of frustrations, and some opinions about this area of development that almost no one has ever been taught how to do. And so it like gave me confidence that there is interest in this topic and developers do want to do better. So because I've put so much thought into code review over the years and so much effort into being better at it, I think I've gotten okay at it. Of course, I thought that previously and I was totally wrong, so who knows. But anyway, a few months back, I tried to really nail down the steps that I use in my personal approach to reviewing other people's code. And that's what I want to share with you tonight. Before we begin, I want to make sure we're all on the same page with terminology. I've already used this term a few times, so maybe I should have started, but the only industry jargon I'll be using is PR, which stands for pull request. If I use other jargon, please just like stop me and make me explain it. Because I don't want to seem inaccessible or unapproachable. I don't want to lose people. Anyway, pull request, sometimes it's called, depending where you work, it might be called merge request, change list, diff. These all mean the same thing. If you want to argue about that later, I'm open to it. I'm curious, does anyone work somewhere where they have a different term that I haven't listed? No, okay. I want to make sure my list is exhaustive. Great. So let's get started. So I've broken down my process into 4 phases. The first one is take a bird's eye view. The second one is reconnaissance. The third is neutralize major threats. And the fourth is the final push. If this sounds military themed, I mean, I'm not, like, code review can be kind of a battle, so. Anyway, I'm gonna go through each phase in more detail. So phase 1, bird's eye view. The idea here is get a high level picture of the task ahead. So let me explain more. So essentially, the goal of this phase is to answer one key question, which is this a one-person job? If it is, that's great. We can move right on to phase 2. If it's not, we don't pretend that we can actually review 1,000 lines of code. We don't just suck it up and do a bad job. We send it back to the person who wrote it and politely say, like, could you split this up into smaller pieces? Obviously, there's some cases where a PR has to be huge and you can't split it reasonably, but in that case, there are ways to make it more reviewable. And those are edge cases anyway. You can almost always split it up. And we can go into edge cases. I have a whole blog post about that. There's not enough time to do it in this hour, but it's a great conversation. Anyway, so the idea here is that we want to determine the size of the pull request. If the size turns out to be overwhelming, then we would say this PR is not reviewable, and we send it back to the author. Now, measuring the size of a piece of software is yet another topic that we could easily talk about and debate all night. But in this case, the goal is kind of just determining if it's reviewable, not like measuring size of software to use for some sort of like comparison. We just need a rough idea. We don't need extreme precision, so we can keep it simple. So some good proxies for the size of a piece of software are the number of files changed, the number of lines changed, and cyclomatic complexity. This is just my opinion. So this is also like very much open to debate. And I'm going to talk through each of these metrics in more detail, but first I want to talk about this idea of reviewable, which is this word I've been throwing around. So let me first read the definition to you. A PR is reviewable when it is structured to minimize the reviewer's cognitive load, allowing them to focus their limited energy on thoroughly scrutinizing the proposed changes. So I have written this definition. It's not taken from somewhere. And I'm sure I haven't invented the word, but I'm trying to popularize it in the industry because, first of all, shared terminology is so important. And this concept is really important, and having a name for it, it's just going to like open up so many more doors. So the idea is we want PRs to be reviewable, and if they aren't, we send them back to be made reviewable. And we don't review things that are not reviewable. All right, so let's talk about these metrics that I've mentioned. So number of files changed. What the question we're really trying to answer here is how many files am I going to be reviewing? And is it overwhelming? Like if there's 20 files changed, that's too much. If it's like a one-line change in each file, that's kind of an exception. So that's why this is not an exact science. And I don't know how productive it would be to set like maximum thresholds for these things. But in general, I'm going to at least say that like 20 is too much, maybe like 10-ish. Now, there's some important like caveats about counting the number of files changed. So I would include deleted files. A lot of times, like in GitHub, if you have a diff, it won't show, or like it won't show you all the deletions necessarily. Or you might think it's deleted, I can skip through it. No, you cannot not review deleted code. You have to check that it's okay to delete it. And I don't mean from a compilation standpoint. I mean, is there information in there that is getting lost if you delete it, and it's going to cause chaos later on? Or bugs and things that the compiler is still going to be able to compile, but you're going to have issues later. Like if you, for example, if you get rid of security, the compiler is still going to work and say this is fine, but obviously you're going to have problems. So you have to you count files that have been deleted in the number of files changed because you are reviewing those. The other big thing about deleted code is that, I mean, it's like the hardest code to review, I think, because you can't just look at what's deleted. You have to go kind of and delete it yourself in your local version and figure out, is there any orphaned code that hasn't been deleted in this change? Because like orphaned code causes so much confusion later on. It is like the bane of my existence. Okay. We don't include generated files when we're counting. We are not going to review those. And I am not talking about files written by AI. I'm not considering that generated code. What I mean here is code where literally you've just written a command, passed it some arguments, and it has created some boilerplate code. In that case, you do not review that. The only thing you would review there is like the arguments you passed to the command, were they the right ones? Okay, and last but not least, we do count non-code files such as documentation. And that's why it's really great to have your documentation under version control and part of your source code repository. It just makes everything so much simpler. Okay, that's number of files changed. Number of lines changed. This one is going to be very similar. We're basically answering the question, how many lines of code will I be reviewing? Is it reasonable? My personal opinion is like 400 lines max, maybe 500. Above that is too much. Humans can only focus for so long. Okay, and same thing here. We're going to include deleted lines of code in that count. We're not including like generated boilerplate, and we are including non-code lines of text. Okay. Essentially, we're trying to gauge how much mental energy we are going to need to review this code. And if we're going to run out of energy way before we finish, it's not reviewable, at least not by one person. So, and that's when we send it back to the author to split up. Now, cyclomatic complexity is my new obsession. I'll be honest, I only discovered this concept like a few months ago. I don't know if I'm the only one who was totally missing this. Everyone else knew about it, never mentioned it in a code review. But anyway, so basically what I'm saying is I'm not an expert here, and I haven't had much time to play around with this. But that's not going to stop me from telling other people what to do. So cyclomatic complexity is based on, this measurement based on the number of linearly independent paths through the code. So really simple, in case you're not familiar with this already. If you have a function and it's got 5 lines of code, and then you have an if-else statement, and then maybe you have 3 more lines, basically there's two independent paths there. We could go through the first few lines, enter the if, go through the last few lines. That's one path. The other path would be first few lines, go through the else, last few lines. Two paths. So that's what cyclomatic complexity is in a really simplified way, but that's really what it is. It doesn't get more complicated. And so you can measure the cyclomatic complexity of like a function, a class, a module, an entire code base. So yeah, it's cool. I should also mention, you could calculate this manually, but you don't need to. There's tools out there, so don't bother. Now, no. Okay. In most pull requests, I recognize that you're often not creating like a new standalone piece of code. Those are kind of the rare exception. You're usually changing things all over the place. So how would you use this in that case? And I want to start doing where I look, say I've changed a function, I'm going to look at the cyclomatic complexity of that function before and after. And if it's too, and kind of like adding up the delta of each measurement and saying like, am I giving this person too much complexity to review? And at this point, I have no like numbers that I can be like, oh, 20 is too much to review or 40 is too much, because I haven't played around with this. But that's kind of my plan for using this. And yeah, if you do actually just create a new function or a class, that's fine. And of course, if you're adding too much complexity, like you can look at this and maybe just make things simpler before sending it off to someone else, or like just, using this as a reviewability measurement that probably comes in a bit sooner, but you could also use it in your code review process. Okay. The bottom line here in this take a bird's eye view first phase is, if it's not reviewable, send it back. I'm really trying to like empower people to send PRs back because I never see this. And selfishly, I just want it to be easier when I do it instead of causing like a huge amount of chaos, because I am not reviewing 1,000 lines of code. I'm not even going to spend time looking at a single line of a 1,000-line change. It is not worth my time. It is not well written. It is not split up. That's not good software development, and my time is too valuable. So that's the end of phase one. And I just want to point out that at this point, note that we have not dug into any code yet. Okay, just keep that in mind. So next is phase two, reconnaissance. The goal here is to understand the mission before diving in. I think like people who play video games probably know what reconnaissance is. I learned it from my brother playing lots of military games. It's just preliminary surveying or research, in case you're not familiar with this term. So for example, if it's like a hiker preparing for an expedition, they're going to do reconnaissance ahead of time, maybe study a map, get familiar with the terrain, check the weather, before they start out on their journey. That's reconnaissance. It's just gathering information before you take action. All right, phase two has 3 steps. First, read the ticket. Second, read the pull request description. Third, mini QA. And I'm going to talk about each one in detail now. So, read the ticket. Why does this matter? Well, basically, you cannot evaluate the solution to a problem before you fully understand the problem. So you have to read the ticket. The ticket represents objective criteria against which you should be evaluating the code, okay? Now, it doesn't represent all of the criteria. It only represents the criteria specific to that ticket. But in general, on a team, in an organization, we have a lot more criteria that our code is supposed to meet, such as being readable and maintainable and consistent with the established architecture, et cetera, et cetera. Those are things your team should have established beforehand and that are not you're not going to list all of these in each ticket. So like we have kind of this general criteria that applies to all the code we're reviewing, and then the ticket is specific to that ticket, to that, the criteria in the ticket is specific to that ticket. So yeah, and then, you know, if the pull request meets all of the objective criteria, it's good, we approve it. If it doesn't meet all of the criteria, we add feedback explaining what criteria it doesn't meet. And it should be like that simple and objective. We need to get all the friction and like the clashes and between ideologies like out of the picture, because a specific code review is not the time for those discussions. It's not. It's too late. And also, if you do that, which I've spent a lot of my career doing, that it's such a waste of time to have the same argument in every little review. I'm having the same arguments multiple times. Me and other coworkers are. It's just duplication everywhere. And as an engineer, this should drive you insane. So yes, reading the ticket also serves to catch miscommunications early. So I think something a lot of people do, and I did when I was, you know, earlier in my career, is I would rely on the PR author's interpretation of the ticket. This is, and I've learned the hard way that you can't, because it doesn't matter if they're smarter than you or they have more domain knowledge or familiarity with the code base. We're all human and make mistakes, and that's kind of the whole point of code review. So that's another reason it's important to read the ticket. When you do read the ticket, you need to make sure you understand everything in it. Even if like it's the most vaguely written ticket and you have to spend the whole day talking to different people and tracking down the backstory, that's just what has to be done. And maybe like suggest some process improvements later. But okay, so what if there is no ticket? At the risk of starting a huge debate, which I definitely don't mind getting into later, I'm going to say that if it requires a review, it requires a ticket, because how else can it be properly reviewed? Okay, step 2. Read the PR description. I am really curious, like, so my question for the audience is, how many of you work in a place where writing descriptions for your pull requests is the norm, as in they're being written on more than 50%? Okay. Okay, so I'll say like 10% of the audience, roughly, maybe 5 people out of like 30, so 1/6, 16%. It's not terrible. I mean, just to give you like a really quick idea of what would go in a pull request description. If you're adding a new feature, in general, if I'm adding a new feature, I'm going to talk about the implementations that I considered and the one that I chose and why, because I want the reviewer to like double check my logic and make sure I didn't make an incorrect assumption or miss something. If you're doing something more like a bug fix, then you would include your step-by-step process of debugging, like finding the root cause of that bug. Because in general, I think we all know, we've all had this experience where it takes you like a week to track down this bug and the fix is like 1 line or less. So the fix, like the actual PR that you're putting up, does not reflect the process that you took to get there. But again, you know, I want someone checking my assumptions. Like, I thought that I took the next logical step each time, but I want someone else to tell me whether they agree. So those are the types of things that would go in a pull request description, other than like some general metadata if you use like PR templates and stuff. So basically, you want to read the description. If the PR author took time to write notes, like read them, they're for you. What if there is no description? I mean, It's not as heinous as having no ticket. In general, no description means there's going to be a lot more back and forth in the review. So, like, I don't know, if you're an extrovert and you love talking to people all day, maybe go ahead, but don't, because like that's just, you should document stuff. But adding a description is just going to save so much back and forth and so much time and so much effort. So I really want to encourage that. Okay. Third step in this phase is mini QA. I think I've invented this term. And this is when you only check the happy path. Because we're not going to do like a full QA at this point. But if the happy path doesn't work, there's no point in reviewing because stuff's going to change. So in this case, what if the code doesn't work when we check the happy path? So best case scenario is that you're testing in a slightly different environment than the developer tested. Like they just missed something small. And you can have like a conversation. Don't put it on like the official PR. Don't clutter up the history with that back and forth. Just go over to their desk or message them on Slack, and they can fix it in a few minutes, hopefully. However, if the code truly doesn't work, like it's a bigger issue than like, oh, I was looking at a different screen size than you were, then we need to like send this back in a more formal way and write something like a message saying what's going on and stuff. So, but yeah, so if it's a small thing, we can like fix it and move forward. If it's a big thing, send it back. All right. That is, oh yeah. Oh, this is a little bit of a mistake. At no point in this second phase did we look at any code, this should say. So still, we're like 2 phases in and we still haven't dug into the code. Okay, phase 3 is neutralize major threats. And don't worry, phases 3 and 4 are much shorter than 1 and 2. Those are the big ones, so we're like almost done. So hang in there. Phase 3, so here we want to address big picture items before focusing on details. The big thing here that I want to impress upon everyone is that we don't review incomplete code. That's not what code review is for. It's for reviewing complete work. So this phase is intended to save time, which is the same as the first phase where we're checking if it's reviewable, because we're not going to waste time on things that aren't possible to review and aren't ready for review. Because if that's what you're doing, then code review is definitely not going to be giving you a return on investment. So you have to have a smart process. So here, what we're going to do is first look at what files have been changed. Hopefully in the previous phase where you've kind of understood the problem and gotten a high-level description of the solution, that paired with like your own knowledge of the code base hopefully has given you some idea of what files you expect to see in that pull request. Just like nothing crazy, but just a general idea. And so you want to like kind of look at what's included, and if it doesn't match your expectations, see, are they doing this differently than I thought, or are they missing something, or is there something extra in here? Next, take inventory of tests. And it's kind of up to you as a software developer to decide like which tests need to be included. Do they need unit tests, integration tests, UI tests, etc.? Whatever kind of test this code change calls for, check that they're there. If they're not there, send it back. It's not ready for review if they're not there. How can they prove to you that this works? They can't. So then third, we're going to take inventory of other big picture items. So this would be things like logging, analytics, documentation updates. Now, I wish that I could create a checklist that everyone could use, but checklists created for the masses are notoriously ineffective. So I can't do that for you as much as I would want to. You kind of have to make one yourself based on the code base that you're working in and the domain and like the kind of development you do also, like front end, back end are going to have different concerns. And make a checklist of like what things should be included in most PRs. If I were to make one and try to include everything on it, you end up ignoring lots of stuff. The more you ignore on a checklist, you just end up ignoring the checklist completely and they're useless. So unfortunately, you have to like make some effort yourself. Now, so here, what's important is that you check for all of these things before you send it back and give them a full list of what's missing. Don't send it back after you're like, oh, you don't have any tests. Like, look for the other stuff too. We want to minimize the number of back and forths in code review. Okay, now, the reason this is important and like that a checklist can really help you is because in my experience, the biggest problems in a PR usually live in the changes that were left out. So it's great to look through that pull request line by line and say, this could be done in a simpler way. This variable needs a better name, la, la, la. But what I found, like the most nefarious things that get through are things that are not included, things that have been forgotten. That's what I've seen where the biggest problems are caused. Like if someone forgets analytics and you send out your new feature and you have absolutely no idea if any users are using it. Or if you forget tests or observability and you're flying blind, basically. Yeah, so that's kind of one of the big things I hope people take away from this, that like reviewing what's in front of you is not enough. It's really only half the story. Okay. Phase 4, the final push. Here we do a deep dive and then we give high quality feedback. So phase 4 has 3 steps. They're very simple. First, plan your approach. I'll explain what I mean by this in a second because I know it's not intuitive. Step 2, execute the approach but without writing any feedback. And step 3, execute your approach again, this time writing feedback. Okay, so let me explain what I mean by this. There's a lot of different ways you can go through a set of code changes. You could go file by file. That's kind of like what ends up happening if you just go through a GitHub diff. You could go commit by commit. You could also do that on GitHub. You can go up the stack or down the stack if that's like how things make more sense to you and helps you catch more. Ooh, I thought I had another one. Ooh, sorry. Oh. Okay, the other one that I was thinking the other day is if you make like an object graph or a flow diagram, you could kind of work your way through that. And this is really up to personal preference. Or some changes are gonna really lend themselves to a specific approach. But it's really not important what the approach is, it just matters that you pick one and stick to it because this is gonna ensure thoroughness and make sure you don't miss things. The second step is to execute your approach without writing any feedback. So the idea here is like that whole seek first to understand concept. And so what I want to say here is like, your initial reactions are useful. Like the first time you read the code, you do want to capture that like, I didn't understand what this method does the first time I saw it, or this name didn't make sense, or I thought this was going to be over here. But then, so those are important to capture those thoughts. So definitely like write that down, but don't make it a formal comment yet. And certainly don't send it to the reviewer. But mainly you want to focus on understanding here. So you need to go through like the entire pull request. And then in the next step, you're going to execute your approach again now with a full understanding, and the second time through is when we add feedback, because now our feedback can be a lot more useful, because we can say, you know, the first time I read this, I didn't understand this variable name, but now because I read the rest, I know what you're going for, and I think we need to include the word secure in this, or take out the word manager, because this really is whatever. So you're going to be able to give a lot more constructive feedback. Okay, and that's the whole approach. So for a quick recap, phase 1 is a bird's eye view where we're asking, is the PR reviewable? Phase 2 is reconnaissance. We're answering what is the problem being solved. Phase 3, neutralize major threats. This is where we determine, is the PR ready for review? And phase 4 is the final push, where we scrutinize, we actually look at the code line by line. Okay, so what do you do with everything I've just presented to you? Try it out. And let me know how it goes. I would love to know if people try this, if it doesn't work for them, if it works for them. I'm really all about feedback. I want to hear your pain points. I want to be challenged. I am not going to be annoyed or offended. In fact, I'd be annoyed or offended if you didn't tell me that you had pain points. Give this presentation at your office. Maybe present this, try and get some culture around code review, or if you're not much of a presenter, you can invite me to give this presentation at your office or some sort of workshop. This is my, I'm not trying to advertise myself here. Don't feel pressure. This is just if you want more information, but there is no pressure. If you don't care about this topic, don't go to my blog. Okay, and I have time for Q&A. And please don't be afraid to challenge me. I'm not going to get upset. I will, if you can stump me, that you'll be my favorite audience member. But yeah, really, I want to hear all of your thoughts.
Not trying to stump you, but
okay, go ahead.
I guess you could go into a bit of the kind of supporting tooling, not necessarily brand stuff, but kind of temporary environments to go along with your mini QA, kind of what metrics are useful for the PR itself. So you were talking about cyclomatic complexity. What would you like to see for that kind of stuff?
Yeah, that's great. So I should repeat. The question is about supporting tooling.
We have the question is on the recording.
Okay.
So did you folks all hear the question? Yeah. Yes. YouTube, did you hear the question? You good? They're good. They told me they're good.
Okay, so this is a great question. Metrics. So yeah, I kind of didn't include any of this because that's more towards the automation. Well, the metrics part is towards the automation side, which is I fully believe that anything you can automate in your code review. The first things I reach for is code coverage, cyclomatic complexity, obviously number of lines changed and deleted. But then I think, and running all of the tests on your CI pipeline and giving a fail pass. Obviously that gets complicated. Some tests take forever to run, and then you have to have these very compromised solutions where you just pick a few and then you run the full thing overnight. Really unideal. But I think thinking from the last place I worked, a lot of the metrics that we had automated, that was kind of this was sort of our ready for review, the looking for the big picture items that would happen before a person actually starts reviewing. And so, but I feel it was quite custom to what we were doing. So for example, this was a mobile application and it was available in maybe 10 different languages. So one of the metrics on our pull request was, are the translations there? We also had a test version of the app that would make sure you didn't break that. And I don't know, I don't have that many great examples right now, but Yeah, I have to think more about like what are the metrics that everyone could use. But I'd say if there is anything you run as a developer before sending your code off to review, you want to just stop doing that and just add it to the CI pipeline and have something that says like, yeah, this is ready for human review now because all these things are here. For the temporary environments, I'm guessing you do more cloud stuff.
Web, Terraform.
Okay,
So
yes.
as long as your deployable unit is of a right size, it's visible,
Yeah.
like a UI and an API
Yeah, so
combination.
this is like an area that I am not super familiar with. My brother does like cloud stuff, and he always tells me these things. I'm like, that can't be right. But so I've always worked on mobile applications, which like you don't really need any temporary environments.
No.
So this is not a problem that I'm very familiar with, but I'm glad you mentioned it because clearly it's something that I need to like look into and add to my whole process. So thank you for that. But I wish I had a good answer, but I don't at this point.
I'm from like a academic research software engineering background, so I'm not familiar with the phrase happy path. So maybe I'm missing something. But it seems to be that I sort of understand that if you're doing like a UI thing, right, you can sort of open it up and follow the trajectory you expect of the application. But in your phase 2, if you're doing very much back-end geared things, I would feel like you would have to end up looking at code to sort of see what the calls would look like and so on to check if it's going. I'm just wondering if I've missed something in that.
No, totally valid question for sure. I am not a back-end developer, so I can't give a great answer, but okay, so I see what you're saying. Like the happy path on the front end is very obvious and easy to test because you can do it looking at a UI, right? So I would say this is not always the case on the front end. Like if I add, it's the case a lot of the time, which is great. But if I add an analytics framework, looking at the UI isn't going to tell me that I've added it correctly and that it's working. So in that case, I have to check, I have to run the app and then check the analytics dashboard somewhere. So I imagine that back-end development is similar. Please do correct me that there's something you can look at, whether it's like a bucket you've created in AWS that like has stuff in it. I don't know. I'm really not familiar. Or if it's like logs that would come out. But I think there is usually some artifact that you can check to check that the happy path works. That's my best understanding. But yeah, definitely anyone feel free to tell me if I'm wrong. It's something that I would love to have kind of like an answer for each type of development, each sort of circumstance, and say like, this is how you check the happy path here. And even like, these are the kind of things you want to include in your pull request description. Like include some of the logs, like a file or a photo, whatever. Include a photo of the analytics dashboard to prove. So, then when it stops working in 3 months, you can go back and be like, it definitely worked there. It wasn't me going crazy. Just like leaving evidence behind is really helpful. So yeah, that's an excellent question for sure.
All right, got time for one more? There you go. Since you're closest.
Lucky me. Thanks for the talk, by the way. And I'm a great believer in code reviews, and I think they are vastly underrated. And I cry a little bit every time I see stuff where that's not part of a central part of the process. But I was wondering, just as a slight challenge, do you think that firstly, what do you think is the purpose of code reviews? Because I think there's lots of different purposes. And one of the big ones for me is knowledge sharing as much as anything within a team. But one thing I was wondering is, do you think there are situations where perhaps you don't need to do code reviews?
This is such a good question. Okay, the purpose. When I first decided like I am gonna die on the hill of code review, I was like, I am gonna drill down and find the ultimate like purpose of code review. And I just kind of ended up with these like super long lists that was listing like 20 different purposes, and realized like it's kind of up to the organization to decide like what is the purpose for them. Is it like quality for their users? Is it developer experience? And so I think, and I know this sounds like I'm taking the easy way out with this answer, but it's really up to the organization to define their purpose for it. And doing that really clarifies like what is important and what isn't in that process, and allows you to like get rid of stuff you don't need to be doing and streamline your process. And I have thought about being like, ooh, I can be a consultant and I will help organizations like define the purpose of their code review process. And like, maybe that is something I will do. But it is, I think, like, so this is all about my personal approach to code review. And I think there's like a big difference between personal approach and like team or organization approach. And when you create like an organizational process around code review, you really have to start with like, what are we trying to do here? Because otherwise you're just like flailing around in the dark. So that's a really good thought. Now, knowledge sharing. This is really interesting because I always used to be a huge like, and it's great for knowledge sharing, you know, as like a selling point. And I have kind of, I read this blog post on Medium that kind of changed my mind about that, and is kind of like, it was this guy, I think he's like the CTO at Cuvva, C-U-V-V-A. They do like car insurance stuff. His idea was that knowledge sharing, that stuff should be in documentation. Like any knowledge that you're sharing needs to be in, not, it should also be like in the pull request, and knowledge does get shared, but it's probably not ever gonna be your primary purpose for code review. And I really like that because, you know, you might change your like source code repository management system from like whatever GitHub to Bitbucket, and then you've just lost all of the information in the PR description, obviously not in the code. The other thing there, I've heard an argument that like your commit messages should include like a lot of documentation as like, this is why I made this change, and they should be reviewed because they're the closest thing to the code and the thing that you don't lose if you change your ticketing system or your code collaboration system. Okay, so the last bit, are there times when you don't need code review? I think yes. I'm a little scared to say this because the last time I said it, like a guy like came at me like this was crazy, but I think if a change is like completely, you know, like we have code review and we have QA, and I really think of them as two separate things. And if a change can be reviewed just through the UI, like I think that's okay. And you could skip the code review, or like the reviewer doesn't need to look at the UI, they just need to look at the code. I'm not sure, but it's an idea I'm open to trying, that like visual changes do not need code review, things like that. But yeah, I don't know. I think like the thing to remember with code review is like there's two users for all code. There's like the end user and there's the developer who's going to read the code next. And I do think code review is more about the developer who's going to read the code next, and QA is more about the end user. That's kind of like where my thoughts are now, but I might completely change my mind in a few months or after different experiences. Yeah.
When you do, come back and tell us about it.
Okay, yeah.
Thank you, Erin.